All right, let's get started with today's lecture, today's content. So, the first big topic of today is absolute value, the absolute value function. Now, the absolute value of x is defined to be x itself if x is greater than or equal to 0. Otherwise, it's negative x if x is less than 0. That's the definition of the function. So, two possible outputs for a given input. Right? So if I say the absolute value of 3, what does that equal to? Well, first off, is 3 greater than or equal to 0? It's greater than or equal to 0? Yes. So you just plug out whatever we plugged in. If our number is greater than or equal to 0, just spit it out. What's the absolute value of negative 3? Well, let's see. Negative 3 is less than 0, right? Yeah. So what we're plugging in is less than 0. So that means spit out the negative of whatever you put in. If you put in x, we spit out negative x. We put in negative 3, so we spit out negative 3. Now we happen to know that negative 3 is the same thing as 3. So the answer is just positive 3.
Oh, okay.
Let me try something more convoluted. I tell you A is a number less than 0. That's all you know about A. What number is it? I don't know, but it's less than 0.
Anything less than 0?
No, it's some number. We just don't know what it is. Okay, so now I ask you, what is the absolute value of negative A?
Negative A. Negative A.
What's the absolute value of negative A?
No.
Negative
Yes,
A.
it is.
Parentheses, negative A.
Well,
Parentheses equals A. It's the same exact concept. You just plug in a different variable, but it's still.
So I'm going to give you the answer, and it sounds like you all got it wrong. The answer is negative A. Okay, but why? Because you're not paying attention to the definition, and all you're thinking in your head is get rid of the negative sign, get rid of the negative sign. No, that doesn't always work. Pay attention to your definition, and let's go over this again. First off, A is less than 0. Right? That's what I told you. So negative A is greater than 0. If A is less than 0, then negative A is greater than 0. A could, for example, be negative 2. So then negative 2 is greater than 0. A is a negative number. So now, what's the absolute value of negative A? Let's come up here. Absolute value of negative A. Is negative A greater than or equal to 0? Yes, so you just spit it out. So the absolute value of negative A in this case is negative A. So you don't just drop the negatives without thinking. Think about the definition. Don't look for a trick. Think about it. So negative A, is that greater than or equal to 0? In this case, yes, it is. Negative A is greater than 0. If A is less than 0, negative A is greater than 0. Which means that negative A is greater than or equal to 0. And so the absolute value of any number greater than or equal to 0 is just that number. There we go. Okay. So that is the definition of absolute value. Now you're going to be solving equations with absolute value. You're going to be given, start out with a really simple one, you're going to be given something like absolute value of x is equal to 13. Now what is this saying? What are all the numbers I could plug in for x such that when I take its absolute value I get 13? 13. I could plug 13 in there. So x equals 13 is one solution. Is there another solution?
Yeah.
What?
Well, if you put in numbers times themselves,
What value could I plug in for x so that when I take its absolute value I get exactly 13?
Equals negative.
X equals negative 13. That's another solution. If you plug in negative 13 for x and take its absolute value, what do you get? 13. If you plug in positive 13 for x and take its absolute value, what do you get? 13. So both these solutions give us 13. So there's two possible solutions to this equation. And those are the only two. Pick any other number you want and plug it in there. You do not get 13. Right? So you're finding all the numbers you can plug in here so that you get 13 to come out. Or in other words, so if I knew that the absolute value of x equals 13, then that gave me that x equals the positive version of this, or x equals the negative version of this. You with me? If x equals 13, what's the absolute value of 13? 13. If x equals negative 13, what's the absolute value of negative 13?
Negative.
Still 13. Sorry. Absolute value of 13 is equal to 13. Absolute value of negative 13 is equal to, right, negative 13, which is the same thing as 13. Right? So these are the two numbers I could have plugged in for x such that 13 comes out. There's no other number I could have put in. If I want 13 to come out, the only numbers I can plug in are 13 and negative 13. Nothing else would work. Correct? Now I'm going to rewrite that y, or that x, in a fancy way. I'm going to write this as the absolute value of y minus 2 is equal to 13. If the absolute value of this thing is equal to 13, then this thing must be equal to 13, or this thing must be equal to negative 13. So that gives me that my x is equal to 13, or my x is equal to negative 13. Yeah, so you're going to solve for the variable now, y. So in this case, it's going to be y equals 15, or y equals negative 11. Notice that both those numbers spit out 13. Plug in 15 for y. What's 15 minus 2? 13. Absolute value of 13 is 13. Let's try negative 11. Negative 11 minus 2 is, no, negative 13. Now take its absolute value, 13. So when you're doing these absolute value equations, it's like you're doing two equations in one go. So come up with another one. If I have x minus 7 absolute value is equal to negative 2. Maybe this is too tricky right out the door. Let's start with 2 and we'll come back to negative 2. Okay, so if the absolute value of this thing is equal to 2, then this whole inside has to either equal 2 or this whole inside has to equal negative 2. Yes. No. One step at a time. So we have x minus 7 has to equal 2, or x minus 7 has to equal negative 2. This whole inside part has to either be 2 or negative 2. That's the only way that's absolute value can equal 2. So from here, we plus 7 to both sides, and we get x equals 9. Or here, we plus 7 to both sides, and we get x equals 5. So x equal to 9 or x equal to 5 are the two numbers you can plug in here so that you get 2 to come out. What's 9 minus 7? Take its absolute value. It worked. What's 5 minus 7? Take its absolute value. It works. Amazing. Easy as pie. Okay. And then we'll get more complex ones. I don't know if I have to be careful to pick numbers that come out nicely or not. We'll just throw it in and see what happens. The other way you're going to see these problems is you're going to have x minus 7 is equal to the absolute value of something like 2x plus 3. Good grief, what on earth are we going to do now? So, we kind of have two scenarios to look at. This could have been a positive, we kind of have four scenarios. This could have been a positive number plugged inside the absolute value. Remember that there are always these plus or minus solutions. So we can look at when this is a plus solution and this is a plus solution. We can look at when this is a plus solution and this is a minus one. We can look at when this is a minus one and this is a plus one. We can look at when this is a minus one, this is a minus one. Those are different combinations that we need to look at. Now notice that looking at when they're both positive is the same thing as both of them being negative. If this is negative and this is negative, we can multiply them both by -1 and they come out positive and positive. In other words, what I'm telling you is that negative A equal to negative B is the same thing as A equal B.
Right.
So looking at the case where both of these are negative and where both of them are positive are really the same case. So these two are actually the same case. And then these two are actually the same case. Because if we make one negative and one positive, so negative A equal to B, is the same thing as multiply both sides by -1, that's the same thing as A equal to negative B. So, when we have a problem like this, maybe we should start out with it really simple. Absolute value of x equal to absolute value, well, I don't want to introduce two variables. Absolute value of x equal to absolute value of x might confuse you. We can just do a 1 here. Absolute value of x is equal to absolute value of 1. So we could have the positive version of this. It could be x, positive x is equal to positive 1. Of course, 1's a constant there, can't we? So we can't plug in other things. Or negative x is equal to 1. That wasn't a good example because this isn't a variable here. And if I just do x, we can do x. Absolute value of x is equal to absolute value of x. We can look at this one. No, because those are the same variable. All right. I'm trying to be too tricky. These are the types of problems that you're going to get. So you have the four possible combinations. This one's positive, this one's positive, this one's positive, this one's negative, this one's negative, this one's positive, this one's negative, this one's negative. Really, we just need to handle the case where negative and negative and positive positive are really the same. So we need to handle the case where we take both the positive values. So we're going to look at x minus 7 equal to 2x plus 3. And then we're going to look at one where the signs differ. And so we're going to look at x minus 7, and we're going to make this one negative, equal to negative 2x minus 3, like that. These are going to be all the solutions that work for that. When we plug in the same number for both of these, and then when we plug in a positive one in one and a negative number in the other, is when they're going to be equal. So these are the two scenarios that you need to handle. So it's like you're solving simultaneous equations again. Solving two equations at the same time. These are your two equations. And it's only 2, it's not 4. Just like what you had before. So over here you had x minus 7 is equal to 3. We already did a problem like this, right? And how did we solve this? We said x minus 7 is equal to positive 3, or x minus 7 is equal to negative 3. And we multiply this by -1. When you have two absolute values, turns out you can do the same thing. You can do the left-hand side equals the right-hand side, or you can do the left-hand side equals the negative of the right-hand side. And it all works out. And you might think, don't we have to handle 4 cases, where here we only have to handle 2? And the reason is no, because 2 of our 4 cases are actually the same. And so it's still just 2 cases. So it turns out it's the same process. So you got the absolute value sign. You do, it equals the left-hand side when it's positive, and then it equals the left-hand side, it equals the right-hand side when it's positive, and then it equals the right-hand side when it's negative. When you have the absolute value there, it's the exact same process. X minus 7 equals the positive version of that, x minus 7 equals the negative version of that. And then you solve these two equations for your two x's. So continuing with this equation, what do we get? Move the x, I don't know if these ones are going to have numbers that come out pretty. Let's use the author's example so I don't run you down an algebraic hole where we get with messy numbers. So those are going to be the two big ideas with absolute values. And That is the majority of the new material for today. Outside of that, it's pretty much just vocabulary and how to understand our vocabulary. Thank you. Okay, so erase all this. Hopefully that doesn't get on it. So let's go through some of the author's examples. Okay, we didn't do one quite like this. So looking at this one, we have 5 plus the absolute value of x is equal to 8. What should we do first?
You want to move 5 over to the other side?
Move 5 over to the other side. If we only have one absolute value in our equations, get that absolute value on the left-hand side, everything else on the right. And so we're going to rewrite this as absolute value of x is equal to what? 3. We subtract 5 from both sides. Right? Now, if the absolute value of x is 3, what does x equal? It equals the positive of that and the negative of that. So whatever is in our absolute value, in this case it's just x, is equal to the positive of that, or it's equal to the negative of that. X is equal to 3, or x is equal to negative 3. Okay? Let's try another one. Here we have negative 4, absolute value of x is equal to negative 20. What are we going to do with that? Divide both sides by negative 4, right? So we divide by negative 4 here, we divide by negative 4 here. Negative 4 divided by negative 4 is? Negative 4 divided by negative 4 is? Negative 4 divided by negative 4 is 1. 1 times anything is just that thing. So we get absolute value of x is equal to negative 20 divided by negative 4 is positive 5. And now, if absolute value of x is equal to 5, what does x equal?
X equals 5, or x equals negative 5.
5 or negative 5. Fantastic. Okay. Next example. 5 absolute values of x minus 4 is equal to 26. What do we do first? Remember, we're trying to get this absolute value of x by itself. Same thing as when you just had an x there, and you tried to get by yourself.
Do you want to add 8 and 4 to both sides?
Yes, first step, we're going to add 4 to both sides. We want all our x's over here and everything else over here. So add 4 to both sides, and what do we get?
30.
We get 5 absolute values of x is equal to 30. Okay, now what do we do?
Now you divide 5 over both sides.
Divide both sides by 5.
You get
5 divided by 5 is?
1.
Hey! And 1 times the absolute value of x? It's just the absolute value of x. 1 times anything is just that thing. 1 times SpongeBob is? SpongeBob. All right, is equal to 30 divided by 5. What's 30 divided by 5? 6. So we get absolute value of x is equal to 6, or in other words, x is equal to 6 or x is equal to negative 6. There's 2 solutions. There's 2 numbers we could plug in for x to make this true. 6 works, negative 6 works. No other numbers you plug in make it work. I'll get it later. Okay, let's try another one. All right, we got the 2x minus 1 equals 7. So we already got the absolute value thing by itself. Okay, shoot, now what?
Oh, 8.
So we have absolute value of something is equal to 7, right? So this something has to either be 7 or negative 7. So I know that 2x minus 1 has to be 7, or 2x minus 1 has to be negative 7. This whole thing has to either be 7 or negative 7 in order for its absolute value to be 7. There's only 2 numbers whose absolute value are 7. That's 7 and negative 7. So if this whole thing is a number whose absolute value is 7, this whole thing has to either be 7 or negative 7. So 2x minus 1 is equal to 7, or 2x minus 1 is equal to negative 7. We're going to get two solutions. There's going to be two x's we can plug in here to make this true. Okay, so if we start with this case, 2x minus 1 equals 7, what do we do? Plus 1 to both sides gives us 2x is equal to 8, divided by 2 gives us x is equal to 4. All right, yeah, you guys are just doing it all in your head. Okay, for this one, what do we do?
Put it the same side.
Same thing. Add 1 to both sides. If we add 1 to both sides, negative 1 plus 1 is? Zero. So we get 2x plus 0, or in other words, we just get 2x is equal to negative 7 plus 1 is what? Negative 6. Negative 7 plus 1, negative 6. Divide both sides by 2. X is equal to negative 3. These are the two magic numbers such that when you plug in here, you get 7. Plug in 4. What's 2 times 4? 8 minus 1 is? Absolute value gives you? Root. Try this one. Negative 3 times 2 is? Minus 1 is? Absolute value of negative 7 is? 7. And so these were the two numbers that worked. These are the only two numbers that worked. You can stay up all night trying different numbers, plugging them in. No other number is going to come out 7. These are the only two numbers that will make that spit out 7. That's what we're looking for. Okay. Slightly more convoluted one. Let's give it a go. Okay, so we got this big mess. First thing we need to do, get the absolute value by itself. So what do? Subtract 2 from both sides. So subtract 2 from this side, subtract 2 from this side, and we're going to get negative 4 times the absolute value of 2x plus 3 is equal to what? Negative 20. Negative 18 minus 2. You owe me $18. Then you owe me $2 more. Now you owe me $20. Right? Okay, now what do?
Divide by negative 4.
Divide both sides by negative 4. Negative 4 divided by negative 4 is?
1.
Negative 4 divided by negative 4 is? 1. Times the absolute value is that absolute value. Okay. And negative 4 negative 20 divided by negative 4 is? 5. And so we're left with absolute value of 2x plus 3 is equal to 5. Okay. So now we got to here. Now we know what to do, right? What do? You can't subtract 3. That's stuck in an absolute value. How do we get rid of the absolute value sign? The way we get rid of the absolute value sign is we split it into two equations, and we solve them both simultaneously. So what are my two equations I get?
2x plus 3 equals 5. 2x plus 3 equals negative 5.
Fantastic. We split it into these two equations. If the absolute value of this whole thing comes out 5, then this whole thing had to either equal 5 or this whole thing had to equal negative 5. Right? So getting rid of our absolute value, that's when you split your equation into two. And now you're getting two answers. If you got an absolute value problem, you're going to have two answers, unless it's the absolute value of 0. So now we've got these two equations that we got to solve. All right, looking at the top equation, what do we do first? What do we do first?
Subtract 2 from both sides.
Subtract 3 from both sides. And what do we get?
2x equals
2. Or we get x is equal to?
2. 1.
We're just dividing both sides by 2. So x is equal to 1. No negatives. Okay. Over here, what do we do first? Subtract 3 from both sides. Same process. 2x equals negative 8. Good. Now divide both sides by 2, and what do we get? X is equal to negative 4. So 1 and negative 4 are our two solutions. You go plug 1 back into this monstrosity. Let's see what we get. 2 times 1 is, plus 3 is, absolute value of 5 is 5. 4 times 5 is 20. 2 minus 20 is? 2 minus 20 is? 2 minus 20 is? Negative 18. Ah, it worked. Okay. Let's try negative 4 now. 2 times negative 4 is?
Negative 4 is negative 8.
Negative 8. Negative 8 plus 3 is?
5.
Negative 5. Now take its absolute value. 5. Absolute value of negative 5 is 5. 4 times 5 is? 2 minus 20 is? Negative 18. There we go. They worked. What are the odds? Probably like 86%. Probably. 1, negative 4. Yay, same answers as the author. Okay. Let's do one of these ones now, where we have two absolute values. Okay. So, I told you when you have absolute value equals the absolute value, you can pretty much ignore the absolute value on one side. Because it's just recounting the exact same cases. Doesn't matter which side you ignore it on, we're just going to pick the habit of ignoring it on the right. Okay? So, we start with absolute value of 2x minus 7 is equal to 4x plus 6. Well, now we want to get rid of this absolute value. And the way we do that is we split our equation into two equations. So we split it into the equation where it's equal to the positive version of this, and we split into the equation where it's equal to the negative version of this. So I have 2x minus 7 is equal to 4x plus 6. And I have 2x minus 7 is equal to negative 4x minus 6. Make sure you distribute the negative all the way through. And now we just solve both these and we're going to get two different answers for our two solutions. So going with this one, what should we do first?
Get your common.
Move your x's over there.
What are they called?
So you do subtract.
Do I want the x's on the right or the left? Pick a side for your x's and then put the constants on the other side. You want the x's on the left or the right? As a general rule, it's better to put the x's on the side that already has more. As a general rule. It just makes like you'll avoid dealing with negative numbers. No reason we could have done the left, but typically it's better to do on the right. Or typically it's better to do on this side for this problem. So we're going to subtract 2x from both sides, right? That's going to put all my x's over there. That means I want all my constants over here. So how do I get all my constants on this side? How do, subtract 6 minus 6 from both sides. Perfect. Okay, and let's see what that gives me. 2x minus 2x is? 0. Negative 7 minus 6 is? Negative 13. Okay, this is equal to, over here, 4x minus 2x is? 2x. And 6 minus 6 is? There it is. All right. So, negative 13 is equal to 2x, or in other words?
7.5. Oh, sorry.
X is equal to negative 13 halves.
Oh.
Just divide both sides by 2.
So then when the other one be x is equal to 13 halves, or it's just those two?
So far, we just have one answer.
Oh, right, sorry, I forget.
We still have this other equation.
Yeah.
So now let's come back and deal with this one. All right, what are we going to add to both sides? So first off, do I want my x's on the left or the right? On the left. The one with more. What's more, having $2 or owing me 4? All right. So we're going to add 4x to both sides. Get the x's over here. And now we're going to do what for the 7? Add 7 to both sides. Good. Okay. 2x plus 4x is 6x. Negative 7 plus 7 is
0.
Good. No more ones. Negative 4x plus 4x is 0. Negative 6 plus 7 is 1. There's our 1. So that gives me x is equal to 6. Except it's reciprocal. 1/6. Not 6. 1/6. I need 6 1/6 in order to get 1. Okay, so x equals negative 13 halves and x equals 1/6. X is equal to negative 13 halves, x is equal to 1/6. Yay, we got it. Okay, and then you have your homework problems. So that's it for absolute value. Pretty simple, right? That's the hardest section, in my mind, that you'll be covering today. Next section is on two things, varying directly or varying indirectly. Or directly and inversely are the two ways that we say it. Now, one thing I might say is that, what's a simple example off the top of my head? The amount of weight in this room is directly proportional with the amount of people in this room. The more people in here, the more total weight in here, right? So the way we represent that is the weight is equal to the number of people times some constant. That's kind of a bad example because we all have different weights, but imagine we all weighed identically the same amount.
Okay.
Then the weight in this room would always be equal to some constant times the number of people in this room. They are directly related. They are directly proportional. The more people, the more weight, and the more weight, the more people. That's directly related.
Oh, this was my favorite one. Finding the constant and then you're putting it in.
Yes, that's how you'll be solving these. So in general, if y is directly related to x, then y is equal to some constant times x. And if y is inversely related to x, then y is equal to some constant divided by x. That means as y goes up, x goes down. Here, as y goes up, x goes up. And as x goes up, y goes up. Here, as y goes up, x goes down. And as x goes up, y goes down. Let's make this quick with your intuition for a second. Let's say y is equal to, we'll pick some constant 100 over x. Whatever that means, who cares? If I make the denominator bigger, then does this whole number get bigger or smaller? What's bigger? 100 over 1 or 100 over 1,000? 100 over 1 is much bigger than 100 over 1,000. So as the denominator gets bigger, the whole number gets smaller. Y is equal to the whole number. So as x gets bigger, y gets smaller. That's what we mean by they're inversely related. On the other hand, when your equation looks like this, if it was y is equal to 100 times x, now x and y are directly proportional, directly related. Now as x gets bigger, y gets bigger. Here, as x gets bigger, y gets smaller. That make sense?
Yes.
So they're going to be giving you equations. They're going to say these two values are directly related, means it's going to be something like y equals k times x. Indirectly related means y is equal to k divided by x. And we're going to be often looking for what that k is, the constant. So rather than me trying to make up examples off the top of my head, let's just steal the author's examples that he's taken the time to think up. Okay. Da, 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 da. Okay, so here's an example. So W is directly proportional to Y. What does that mean? That means W is equal to some constant times Y. They're directly proportional. As W goes up, Y goes up. And as Y goes up, W goes up. Next, we're told that when W is 50, Y is 5. So that means 50 is equal to K times 5. Right. So now we're solving for whatever that constant is. Divide both sides by 5, and you get 10 is equal to K. So our formula, our constant was actually 10. So our formula is W is equal to 10 times Y. That's the actual formula. So we figured out what the constant was. So we knew initially it looked like this, and then we used our other information to figure out what the constant is. That's how these problems are going to work. Let's look for another one. All right, C varies indirectly as D. So C is equal to some constant over D this time. Now they're indirectly related or inversely related. As D goes up, C goes down. If D is a bigger number, C has to be a smaller number. Now we know that C is equal to 4.5. You okay with me just writing that as 9/2? 4.5 when D is equal to 6. So I plugged in 4.5 for C, plug in 6 for D. Now I'm solving for K. What am I going to do? What am I going to do?
Aren't you going to multiply it?
I don't know how else to get rid of the denominator.
Oh, multiply it by this, so times 2 by 3.
If you multiply 2 by 3, you get 6.
Right.
Multiply both sides by 6. We're trying to get the K by itself.
Oh, yeah, sorry.
Right?
Yeah.
So multiply both sides by 6. So take this, multiply it by 6. Take this, multiply it by 6. Okay, 9/2 times 6 is equal to... Remember, 6 is the same thing as 6 over 1. 2 goes into 6 how many times?
3.
So this becomes a 3, and this is a 1, and we're left with 27 over 1, which is 27, is equal to K, because the 6's go out. Because 6 divided by 6 is 1. And 1 times K is? There it is. So in this case, K, our constant, is 27.
I don't know how I explain this. This is so much easier than what I like.
Some people try to over-explain it. And yeah, I even explain it different than the author does. I don't like his way of saying it. I think it gets more confusing. Okay, let's try another one. X is jointly proportional to Y. Jointly proportional. What does that mean? If X goes up, does Y go up or does Y go down? It goes up. Jointly proportional is the same thing as directly proportional. They're related together. So, if X gets bigger, Y gets bigger. So, oh, sorry, was there a Z? Oh, Y and Z, sorry. So, X is jointly proportional to both Y and Z. So, X is equal to some constant, Y times Z. It's directly proportional with Y and Z. In other words, as Y goes up, X goes up, and as Z goes up, X goes up. Yeah. It's proportional to both of them. Okay, now we know that when X is 48, when Y is 2 and Z is 4. What's 2 times 4? That was good. All right, now what?
You're gonna
Divide by 8. 48 divided by 8 is? 6.
Your constant is 6.
Your constant is 6.
Why do they make constants a K instead of a C?
So you can remember it says K. I don't know. Okay. This one now. More of a story problem. Let's try it out. The price of an item varies directly with its sales tax. So price is equal to some constant times our sales tax. We'll use T for tax. Could just as easily use S for sell. Right? Okay.
Price goes up. Sales tax.
Yeah. The more expensive the item, the more sales tax you pay. Pretty straightforward. Okay. If the price you pay is $25, when you have a sales tax of 2, then what's our constant there? In other words, we're calculating what's the percentage for the sales tax. Well, kind of. Okay. So, what is it?
13.5. $13.
So K is equal to 13 over 2. That's our constant.
I think you just
You don't
made
want
up
us to
40.
write decimals.
Oh, now what would the sales tax be on a $40 item? So now our equation, we figured out K. So now our equation is P is equal to 13/2 times T. The actual price is 13.5 times your sales tax. Okay, so now they say, what will the tax be on a $40 item? So if the price is 40, what is your sales tax? So 40 equals 13/2. I'm writing crooked and it's throwing me off. Okay, so we know P is equal to 13/2 times T. Now we're looking for the special case where 40 is equal to 13/2 times our tax. Okay, so we're trying to get T by itself. What do we do?
You're gonna multiply 13.5. I don't know.
By?
On both sides.
Multiply both sides by 13/2.
Or
The reciprocal. Multiply both sides by 2/13. Divide both sides by 13 over 2, but that's the same thing as multiplying by 2 over 13. So that's what we're going to do. And the 13 cancels out with the 13 and the 2 with the 2, leaving 1, 1, 1, 1. 1 over 1, 1 over 1, all times T just is 1. Okay. Now,
Going to it.
2 times 40 is
So 80.
80 over 13. So T is equal to, I guess we'll just write down here, T is equal to 80 over 13. Or if we want that as cents, then your sales tax is $16.15.
But you don't want that. You want it in a mix.
Well, here it's asking for the actual sales tax. So you want to calculate it and actually write the decimal value. Because 80/13 dollars isn't a currency you can give me. I assume that they'd round it. We'll look at their answer.
How did they get?
What did we mess up?
After 25.
Let's see. We found K. K we got.
Oh, it wasn't 13.5, it was 12.5. That's what it was.
All right. We made a dumb mistake.
I was at off by $8.
We made a dumb mistake. Let's restart. Unacceptable. Restart. So we know that price is directly proportional with the sales tax. And we know that when our price is 40, our sales tax was what? 2. I have no clue how we got the numbers that we got. We made a real mess of things.
I thought it's because I did 17 instead of 16. I'll have 17.
No clue what we did before. Okay, but we'll just do it right now. Divide both sides by 2, what do we get? So K is equal to 20. How did we get some word fraction before? What a nightmare. Super easy. Okay, so price is equal to 20 times t. Right? Now we said, what is our sales tax when we pay for, what price was the item? Oh, maybe we were supposed to use a $25 one first. Ah, we were. If I mess up one more time. Okay. The problem says we paid $25 when we had a sales tax of $2. Right?
Right.
So, divide both sides by 2, and we get K is equal to 25 over 2. Right?
Yeah.
Easy as pie. Okay. Now, P is equal to 25 over 2 times T. There's our general formula. Now we said figure out the sales tax when our price is $40. When our price is $40, so we're plugging in 40 for P. We know K is 25 over 2. What is our T? Multiply both sides by 2 over 25. And so, we get 2 over 25 times 2 over 25. Okay, well, before we do that, 5 goes into both these. So how many times does 5 go into 25? 5 times. How many times does 5 go into 40?
8.
8 times. And so we're left with 16 over 5. Right?
Yeah.
Now we want to express this in terms of currency. So let's times top and bottom by 2. And that gives me 32 over 10, which is the same thing as $3.20. Right? Much better. And that's what he has. Okay. Let's try another one. The speed or rate, Josiah travels to work is inversely proportional to the time it takes him to get there. So his rate is inversely proportional to his time. You guys like R for rate or S for speed?
R for 8.
R for rate. Okay. If he travels 35 miles per hour, so when he goes 35 miles per hour, it takes him 2.5 hours, which is 5 halves, right? And then we'll come back and answer it. First, let's figure out what K is. Now, K divided by 5 halves is the same thing as K times 2 fifths. Or, here's a better way to say it. I want to get the K by itself, so I'm going to multiply both sides by 5 halves. So multiply this side by 5 halves, and multiply this side by 5 halves. Right? 5 halves over 5 halves is 1. So I cancel that with that, leaving us just K. Okay, so now we just got to deal with this. 35 times 5?
Is it 5? No.
You're doing 35 times 5. What's 5 times 5?
60.
25. What's 5 times 3?
15.
So 150. What do we get?
175.
175. Okay. So 175 over 2. K is equal to 175 over 2. Right?
Wait, why'd you do it over 2?
I was doing 5 times 35, and we still have the 2.
Yeah.
Okay. So there's our K. Now we're trying to figure out how long will it take him if we travel 55 miles per hour. So R is 55 is equal to K, which is 175 over 2, all over the time. Right? Okay, what are we going to do? We're trying to solve for the time. I need the time to be on one of the sides, but it's down here. Uh-oh. How can I get it back up top? Multiply both sides by a time. Times t times t. What's t over t? What's t divided by t?
1.
It's 1.
1.
Zero.
T over t is 1. So now we're left with, over here we have 55t is equal to 175 over 2.
5. 175 by 2.
Divide both sides by 55. We're trying to get the t by itself. Or in other words, multiply both sides by 1 over 55. Divide by 55, multiply by 1 over 55, same thing. Right?
Yeah. 65.
Now we got 5 goes into both of these. Right? How many times does 5 go into 175?
How many times is 5?
35 times. How did we get 175? We did 35 times 5. So how many times does 5 go into 175? 35 times. So 5 goes into there 35 times. 5 goes into here 11 times. And this is equal to
35 over 22.
35 over 22 hours. They have it rounded here. They say roughly 1.59. Let's see what we get. 35 divided by 22 comes out to 1.59. Okay. Well, this is approximately 1.59, which is what the author gets. Oops. Wait, syllabus. Okay. We'll do one with a square, and then we'll move on to the next section. This one. The area of a circle is directly proportional to the square of the radius. The area of a circle is directly proportional to the square of the radius, to the radius squared. Right? Okay. A circle of radius 10 has an area of 314. So the area is 314 when the radius is 10. If the radius is 10, what's 10 times 10? 100. So 100k is equal to 314. Or in other words, k is equal to what? 3.14. Divide both sides by 100. Yeah, when you divide by 10, move the decimal. When you divide by 100, move it again. Good. Okay, so there's our k. What will the area be with a circle of radius 4? So, area is equal to 3.14. If the radius is 4, then 4 squared is 16. So we do 16 times 3.14. Pull out your handy-dandy calculator. Don't do that in your head. And that's 50.24.
Areas.
50.24, whatever your units are,
Your radius.
when your radius is 4. So if we were to create a radius of 4 feet, so that's a bit more than this, and create a circle with that radius, then the circle we would have marked out would be 50 square feet. Okay, let's see what they got. 50.24. Yay, we did it. Okay.
Reading.
Lots of story problems. I'd hate to take those away from you. Okay. Next section is on how to read story problems and help you understand what the story problem is saying. So, when you're reading a problem, it will often say a number. when you read a number, you should be thinking a variable x. When you read the word is, that often means is equal to. So if you read something like x is 5, we read that as x equals 5. More than often represents addition and is usually built backwards, writing the second part plus the first. So that's a bit hard to understand. Let's read an example. If you're reading and it says, in some problem it says 3 more than a number, well, a number we represent as a variable x, and 3 more than a number is like backwards addition. So this is saying x plus 3. 3 more than a number is x plus 3. 3 more than a number, x plus 3. Less than, same thing but minus. So if I read 4 less than a number, that's that number minus 4. So that's tips on how to read these problems and interpret them correctly. So let's do one now, keeping all this in mind. If 28 less than 5 times a certain number, so 28 less means we got to do subtraction from something. So I know I'm subtracting 28 from something. 28 less than a number, what am I subtracting it from? 5 times a certain number. A certain number is x. 5 times is 5 times x. So this is 5x minus 28.
Equals to.
Is 330 or 232. Is 232. So that's how we read that. 28 less than 5 times a certain number is 232. Okay, that's the hard part. Now it's easy. What do we do? Add 28 to both sides, so we get 5x is equal to, add 28 to that. You said 260 so fast I didn't even hear it.
I know.
There it is. All right, now what? Divide by 5. What do we get? Can't say 52 that fast.
52.
Good job. Divide by 10, multiply by 2. That's how you divide by 5. Okay, so there's our answer. So these problems are real easy to solve. The hard part is just writing them down correctly. Yeah, so
Oh, age problems are
age problems are the worst.
I hate.
Let's look at consecutive integers. What are consecutive integers?
Come after one another.
Integers that come right after one another. So if x is an integer, what is the integer that comes right after x? X plus 1. That's the integer that comes after x. What comes after 9? 10. How do you figure that out? Well, you're counting, but you could have also added 1 to 9. And what comes after 10? 11. So that would be x plus 2. So here's 3 consecutive integers. If x is 9, this is 9, 10, 11. If x is 50, this is 50, 51, 52. Okay. So the sum of 3 consecutive integers is 97. Or 93, thank you. So the sum of 3 consecutive integers. So here's the first of them, plus my second one, plus my third one. There's 3 consecutive integers. And their sum is equal to 93. Now add it up clock-like terms. We have 3x plus 3 is equal to 93. What do we do? Subtract 3 from both sides. We're left with 3x equals 90. Divided by 3. Yeah, so we get 3x is equal to 90. Or in other words, x is equal to 30. Yay, confetti. You did it. Yay. All right. Wow, they really give a lot of explanation for that. This is the same one. Okay. Find 3 consecutive integers. Okay. Find 3 consecutive odd integers.
It's gonna be subtract.
Okay. How do we get 3 consecutive odd integers?
You go behind zero.
X.
So you go negative 1. You got negative 1. Subtract it by 1. 2,
Let me see if they...
3, 1, 4.
They're just counting on the fact that's all going to work out in the end. Do I give it to you right, or should I just give you what they do? Give it to you left? That's all right. Okay. I'm going to give you the definition of an odd number here. Kind of scared to do this. Let's hope you can get this. A number is odd, x is odd, if it can be written as 2 times an integer plus 1. If you can write it this way, it's odd. If you can't, it's not odd. This might be a bit too abstract.
What? How does that make sense?
So give me an example of an odd. Let's pick a different one. 13. Is 13 odd?
Yes.
Oh, yes.
13 is odd. How do I know?
2 times
Uneven amount
2 times 6 is
Because it's 2 times an integer plus 1. If it was just 2 times an integer, it'd be even. But since I have to plus 1 to get it, it's now odd.
Okay. Oh. Okay. That makes more sense.
But I'm thinking that this is a bit too... a bit too much. So we'll just operate on the assumption that the answer he gave us is just going to work. So find 3 consecutive odd integers so that the sum of twice the first, the second, and 3 times the third is 152. Find 3 consecutive odd integers so that the sum of twice the first. So we've got 3 consecutive odd integers. So here's our first one, x. If x is odd, then the next odd integer is x plus 2. It's 2 more than it, right?
Yeah.
And then the one after that is going to be x plus 4.
They're just doubling it.
They're just adding 2 to get to the next odd. What are the consecutive odds starting at 7? They're 7, 9, 11, 13. You're just counting by 2s. Okay, so x is our odd. Here's 3 consecutive odds. Now they said find 3 consecutive odd integers so that the sum of twice the first, so 2 times the first one, the second, and I think that they just mean add on the second, and 3 times the third is equal to 152. Okay, so now multiply it out and combine like terms. So we have 2x plus 2 plus 3 times x is?
3x.
3 times 4 is?
Oh.
Equal to 152. Oops, that's plus. That would come back to bite. Okay, how many x's do we have? Add up all our x's.
6.
We have 6 x's. What are all our constants on this side? 14 is equal to 152. Subtract 14 from both sides, and what do we get? Is that a question?
138.
Just subtract 10, then subtract 4. Or subtract 4, then subtract 10. Nice and easy. Okay, now divided by 6. 23, because 6 goes into 120 10 times, and then 3 more to get the remaining 18. It's what you did in your head? $13? How do you know? Come on, don't check out yet. Hang in there.
Okay.
6 goes into 120. How many times does 6 go into 120? How many times does 6 go into 12?
6 times.
How many times does 6 go into 12? 2 times. Then you got the 0. So 6 goes into that 20 times. Now we have 18 remaining. How many times does 6 go into 18? 3. So we get 23. You guys need to get to the point you can do stuff like this in your head. Shouldn't be a stare at the whiteboard for 3 minutes exercise. Okay. So x equals 23. There's our answer. That was our first odd. So our 3 consecutive. So if they're asking for the 3 consecutive odds, they were 23, 25, and 27. Those were our 3 consecutive odds. Okay. On to your favorite problems, age problems. Now the author tries to talk you through setting up these tables, blah, 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 trying to give you some procedure for filling it out. I think that's a bunch of nonsense. I think you just think about it and write down what you know. Not as procedural as what the author gives you, but it's going to be the way I do it. So let's just go over it. Adam is 20 years younger than Brian. So I'm going to have 2 variables here. I have Adam's age and Brian's age. Right? Adam is 20 years younger than Brian. That means Adam's age plus 20 equals Brian's age. Adam plus 20 is Brian.
Okay.
Or you could have said Adam is equal to Brian minus 20. Adam is 20 years younger than Brian. Adam is 20 years younger than Brian. Both say the same thing. Whatever appeals better to your intuition, go with it. Just make sure it makes sense. You can plug in some numbers. You can ask yourself, well, if Adam's 8, how old should Brian be? 28. Because Brian is 20 years older than Adam. Or Adam is 20 years younger than Brian. So it's real easy to check to make sure you set this up right. Pick an age. All right. In 2 years, Brian will be twice as old as Adam. So if we add 2 to both their ages, then Brian will be twice as old as Adam. So Brian's age plus 2 is going to be twice what Adam's age will be when you add 2. In 2 years, Brian will be twice as old as Adam. Now we've got the 2 equations, the 2 unknowns. You solve for one, plug it into the other. So let's solve it. Over here, we have b plus 2 is equal to 2a plus 4, right? Now from here, I know b is equal to a plus 20. So I'm going to substitute that in down here. Or first I could have subtracted 2 from... When you have an equation, when you have 2 equations with 2 unknowns, always and forever, pick one of your equations, solve it for one of the variables, and then plug in, substitute that variable into your other equation. That's always how you do it. So I already have this one solved for b. So now I'm going to substitute b in here, and that's going to give me what a is. When I have my a, I'm going to plug that back in here, and that's going to give me my b. So that's what you do. When you have 2 equations, 2 unknowns. Pick one equation, doesn't matter which one. Pick one, solve it for one of the variables, plug that into the other equation. That's going to give you one of your answers. When you have one of your answers, getting the other answer is real easy. So, here's this other equation. Here's one equation, here's my other equation. This, I already know what b is. So I'm going to substitute in for b over here. So I'm going to replace that b with a plus 20. So I get b plus 2 is equal to 2a plus 4. And now it's a type of equation that you know and love, right? Really quick, add like terms. A plus 22 is equal to 2a plus 4. Now what should we do? Minus a from both sides. What else? Minus 4 from both sides. Fantastic. 22 minus 4 is 18 is equal to Okay, so Adam is 18. And now how old must Brian be?
38.
38. Brian is 38. So that's how you solve age problems. You can read through how this author is trying to get you to use this table. I think it's way easier to just think about it than to try and figure out how to use the table. So notice he fills out all this stuff. And it makes it just a huge mess. All right, let's do another one. So we start out with Cameron is 12 years older than David. So we have a C and a D. Now, what's my equation there? If Cameron...
Plus 12.
Equals D.
Which is bigger? Who's older, Cameron or David?
Oh, C minus.
Cameron is equal to David's age plus 12. You have to add 12 to David's age to get Cameron's age. Or you have to subtract 12 from Cameron's age to get David's age. Whichever way you want to think about it. Now, chances are, first time you go plug in, you're going to do it wrong. So just do a quick sanity check. Ask yourself something like, if David is 2, how old should Cameron be? 14. Make sure your equation satisfies that. So do a quick sanity check. So there's one of our equations. 5 years ago, so we're subtracting 5 from both their ages. 5 years ago, the sum of their ages was 28. So David's age 5 years ago plus Cameron's age, was it Cameron?
Yeah.
Carmen. Plus Carmen's age 5 years ago was 28. Right? Okay. Now what do? Substitute C in down here. Fantastic. So we got D minus 5 plus C minus 5 is equal to 28. All right, now what?
Combine like terms.
Combine like terms. How many D's we got?
2D.
2 D's. And what's our constants?
12.
Try again. Negative 5, 12, negative 5. 2 is equal to 28. Okay, now what do? Minus 2 from both sides, and we get 2D is equal to? So we get D is equal to? So David is 13. And how old is Carmen? 25. Plug D back in here. 12 plus 13, 25. Make sense? Okay. So those are age problems. Not so bad, are they? Now, our rate, time, distance problems. Okay, these ones are also super easy. You just need to remember one formula. If you are driving 20 miles per hour and you drive at that speed for 3 hours, how far do you go? If you're going 20 miles per hour and you go for 3 hours, you go 60 miles. You said my rate times my time gives me my distance. This is pretty much the only formula you need to remember for this equation. Your rate times your time gives you your distance. Okay? And then they're just going to give you a bunch of different ways where they give you the rate and the distance, solve for the time, or the rate and the time, give you the distance, blah, blah, blah. Same thinking. So let's just jump straight to an example. The author's going to give you these tables. I think tables are a waste of time. I think just think about it. Okay. They want us to solve these simultaneously. What's the best way to say this? So, 2 joggers start from opposite ends of an 8-mile course. So we've got an 8-mile course. This is 8. I've got one jogger starts running this way. And I've got another jogger starts running this way. running towards each other. One jogger, we're going to call this jogger 1, jogger 2. And I'm going to use R sub 1 for jogger 1's rate and R sub 2 for jogger 2's rate. So one jogger is running at 4 miles per hour. The other is running at 6 miles per hour. So the rate of the first one is equal to 6. And the rate of the second one is equal to 4. Right? One jogger is running at 4 miles per hour. The other is running at 6 miles per hour. Okay. Oh, I see what you're saying. Don't want to confuse you, but it doesn't matter. Okay. How long will the joggers meet? After how long will the joggers meet? Okay, missing a word. So in other words, these two are running towards each other. When are they going to bump into each other? They're going to run into each other when the distance that the first runner has run plus the distance that the second runner has run is equal to what? 8. The only way that these two people can meet is if the total distance that they've run is 8 miles. If he's only run 2 miles and he's only run 3 miles, then there's still 3 miles between them and they couldn't have possibly met. So the only way that these two can meet is if the total distance that they both run is 8 miles. So the distance of the first one plus the distance of the second one has to equal 8. Now I know that the first person's rate times their time is equal to the first person's distance. And I know that the second person's rate times their time is equal to the second person's distance. Right? Here's me, here's you. You're fast, I'm slow. My distance that I've run is equal to my rate, 4 miles per hour, times however many hours I've been running. The distance you've run is equal to your rate, 6 miles per hour, times however long we've been running. Our times are the same in this case because we've both been running the same long. We start at the same time running towards each other, right? So the distance I go plus the distance you go has to be 8. What is the distance I go? It's my rate times my time. So my rate times my time plus your rate times times we have the same time is equal to 8. Now what is my rate? 4. What is your rate? So, how many t's do we have? 10 t's is equal to 8. Or in other words, t is equal to? What? Divide both sides by 10. You screwed up. You did 10 divided by 8. Eight divided by 10 is 0.8. Woo. 0.8. See how a calculator breaks your brain, but stopping and thinking for half a second doesn't? That's why I won't let you use a calculator on your test. So you ran for 0.8. We ran for 0.8 hours. Or 4/5 of an hour. Or 48 minutes. Right? Okay, so that's how long till we meet each other. Oh, that was a much funner problem. Let's do another one. Figure out what Bob and Fred are up to. Bob and Fred start from the same point and walk in opposite directions. All right. So Bob, he's walking this way. Fred, he's walking this way. They decide to go their separate ways. Bob walks at 2 miles per hour faster than Fred. Oh boy. The rate of Bob is equal to, Bob walks 2 miles per hour faster than Fred. Bob's rate is equal to Fred's rate, the rate of Fred, plus 2. Right? After 3 hours, they are 30 miles apart. So our time is equal to 30. And I know that their distance the distance that Bob went plus the distance that Fred went is equal to what? Oops, after 3 hours. Time is 3. 30. Just writing down all the information I know from the problem. How fast did each person walk? So we're trying to figure out the rates. Okay, so here's what I know. Always and forever, rate times time equals distance. I know that forever, right? Now, I have all this other information. I know that the rate of Bob is equal to the rate of Fred plus 2. I know t equals 3. That's going to be super useful. And I know that the total distance that they went is 30. The distance of Bob plus the distance of Fred is equal to 30. Okay, so that's everything I know. Now let's pull all together to try and figure out the rates. So start with this and let's substitute in my distances. I know that the distance of Bob, what is Bob's distance?
Bob's distance is the rate of Fred.
It's Bob's rate times his time. So this is equal to the rate of Bob times time plus, what is the distance of Fred? The rate of Fred times his time. I know it has to be 30. Right? I'm just substituting in what I know distance is. Distance is their rate times their time. That's all I've done so far. Now I know what the time is. So 3 of that. 3 of that. Okay. What else do we know? That's R sub B, that's R sub F. Those are different. What else do we know?
That they equal 30 miles.
We can substitute our RBs with RFs. So now substitute that into this. So 3 RB plus 3 R sub F is equal to 30. Right? Now it's a problem that we know and love. We can solve for the rate of Fred. And once we have the rate of Fred, we can figure out the rate of Bob, which is what we're after. So 3 times Fred's rate gives me 3 of the rate of Fred, plus 6 plus 3 of the rate of Fred is equal to 30. Combine like terms, so 6 of the rate of Fred is equal to, I'm going to subtract 6 at the same time. You good with that? 24. Okay, now what? Divide by 6 and we get the rate of Fred is equal to 4. So Fred was going 4 miles per hour. So then what's the rate of Bob?
It's going to be 8 miles per hour, double.
6. The rate of Bob is equal to the rate of Fred plus 2, not times 2. Good? These are far and away the funnest problems we've done so far. Right? Yes! Can hardly contain herself. I know. You're so happy, your tone went all the way around back to apathy. It sure did. All right. Let's do another one. One more. One more. You got this. Don't give up on me now. Always and forever, rate times time equals distance. Always and forever. Okay, so now we're doing this problem. Mike leaves his house traveling 2 miles per hour. I'm just going to start writing down information I know. I have no clue how I'm going to use this later. Just collecting what I know. The rate of Mike is equal to 2. Joy leaves 6 hours later to catch up with him. So the time that Joy takes is equal to the time of Mike. Sorry, Mike's been walking 6 hours longer than Joy. Right? Joy leaves 6 hours later. So when we're looking at the time they've been going, who's been going longer? Mike. Mike's time is equal to Joy's time plus 6. However long Joy's been going, Mike's been going 6 longer. To catch up with him, traveling 8 miles per hour. So we know the rate of Joy is equal to 8 miles per hour. How long will it take her to catch up with him? Okay, if she catches up with him, how far did both of them go? The same distance. So the last thing I know is that the distance traveled by Mike is equal to the distance traveled by Joy. Right? Now, if the distance Mike traveled is equal to the distance Joy traveled, then that means Mike's rate times Mike's time equals Joy's rate times Joy's time. Because distance is always equal to rate times time. So I'm going to substitute out the distances. So Mike's distance is equal to Mike's rate times the time of Mike. Is going to be equal to Joy's rate, the rate of Joy, times Joy's time, the time of Joy. Now, what is the rate of Mike? 2 times the time of Mike, we don't know, is equal to
8.
the rate of Joy, 8, times the time of Joy. Time of Joy, we don't know. Okay, so now we've got 2 variables. We need to get down to 1. Is there any other substitution I can make?
Yes.
What?
Yeah.
Last time.
Right here, TM. I know TM. Let's come plug that down in here.
We do 2.
So 2 times TM, which is T sub j plus 6, is equal to 8 T sub j. Right? 2 T sub j plus 12 is equal to 8 T sub j. So we get 12 is equal to 6 T sub j.
Which is 2.
2. 12 divided by 6 is 2. 2 is equal to the time of Joy. So Joy is going for 2 hours. And how long was Mike walking? 8 hours. Because Mike was walking 6 hours longer than Joy. Mike left. 6 hours later, Joy left. If Joy was out for 2 hours, Mike must have been out for 6 hours or for 8 hours. And let's make sure that's what they get there. Okay. Think we've had enough of that. All right. So you have the rest of the class to work on any homework that you want. Since you guys did so good, we'll say this upcoming week, you only have to do every other odd. So problem 1, problem 5, problem 9, problem 13. Every other odd. So, yeah, you can take a break. You have the rest of the class for homework. Don't think I turned off this.